Hello everyone and welcome. In this video we're going to be explaining chapter 7 of AS Mathematics, series and expansion. The whole concept behind this chapter is just the idea of expanding something or expanding a binomial with an exceptionally high power. Something like x plus 1 to the power of 2 is a pretty common binomial to expand, and we're all familiar with the answer. But something like x plus 1 to the power of 3 is a little less familiar, and in order to expand it, you'd first write it as the following, and then using the information from this part over here, we can expand it, and it's not that difficult. You just distribute, and you're going to wind up with x to the power of 3 plus 3x squared plus 3x plus 1. Meanwhile, if you have something like x plus 1 to the power of 4, you're going to have to expand, x plus 1 squared by x plus 1 squared, which is a little more tricky, and it's going to get us, it's going to take us longer to get to the answer, which is the following. You can see that the number of terms gradually increases, and when it's x to the power of 2, the number of terms is 3. When the whole thing is to the power of 3, the number of terms is 4, and when it's for the fourth power, the number of terms is, you guessed it, 5. Now, some mathematicians, which have been, doing some deep studies of maths, and so know a lot of things that we still don't know, they discovered a pattern, which led them to discover a formula that helps them expand things directly. I'm going to give you the formula. NCR times the first term, in this case it's x. Let's say the power is k, which is supposed to be the total power of the binomial. And then times the second term, which is going to be raised to the power of n minus k. I'm going to show you an example. Let's say something like x plus 1 to the power of 4. So in order to get all the terms, I'm going to start with the first term. The first term is going to be x to the power of 4 times 1 to the power of, well, in this case 4 minus k. What's k? Well, k again is n minus the power here, and so 4 minus 4 is supposed to be 0. You'd multiply this by 4, choose 0. Now you can think of this r as one of two things: either as the number of the term minus 1, so it's the first term, but you're going to subtract 1 from it, so it's going to be just 0, or as the power of the second term, which, as you can see here, is exactly true. Now this is supposed to give us the first term. If you plug 4C0 on your calculator, 4C0 can 4, and then you can choose 0 on your calculator by shift above, I believe, the multiplication or the addition sign. Now, if you use this, you should get the answer to be x to the power of 4. Because 4 choose 0 is 1, and 1 to the power of 0 is 1, and x to the power of 4 is just x to the power of 4. The second term, as I mentioned, we're going to be moving downwards with the power of x decreasing. So x to the power of 3 times 1. Now, as I mentioned, we decrease the power here by 1, but we're going to decrease the power of the second term by 1. And you can see that the powers here add up to give me 4, exactly like the formula said, because this is supposed to be n minus k, and so n minus k. What's n supposed to be? 4, and 4 minus 3 is 1, so this power is true. Now multiply this by 4c in the power of the second term, and that should give you 4c1 is supposed to be 4, 1 to the power of 1 is 1, and x to the power of 3 is just x to the power of 3, and so it's 4x to the power of 3. Let's say something like this third term. The third term is going to be x to the power of 4 times x to the power of 2 times, they're supposed to add up to the power of the binomial, and so 2 plus 2 is 4, and then you multiply this by the power of the second term, and that should give you 6, because 4c2 is 6, 1 to the power of 2 is 1, and 6x squared. Now the fourth term is going to be x to the power of 1 times 1 to the power of 3, because they're supposed to add up to give me the total power of the binomial, then multiply that by 4c3 as the power of the second term, and that should be 4x to the power of 1. Now you can see here as that the power of x is decreasing, and that the power of 1 really is increasing, but obviously that doesn't show in the answer, because 1 to the power of anything is just 1. Now this fifth term, because we have obviously anything to the power of 4 is supposed to have 5 terms, like anything to the power of 3 is supposed to have 4 terms. So the fifth term is going to be when x is raised to the power of 0, multiplied by 1 to the power of 4, and then that's obviously multiplied by 4c4, which is supposed to be 1. Now, as you can see here, the power is going to go from to continue with this pattern and this sequence, going from 0 all the way until the power of the binomial for the second term, and going from 4, or the power of the binomial, all the way until 0. So you're not going to stop until this point is reached over here. Maybe he's going to ask you not for all the terms, but if he does ask you for all the terms, then you're going to have to do this, and then obviously write them out together on one line. 6x squared, 4x plus 1. Now let's try another example. How about x plus 2y to the power of 4? It's a little different, but still to the power of 4. Notice here the second term is no longer 1, but rather it's 2y. Still, the same formula applies. The first term is supposed to be, we get x raised to the power of the binomial, 2y, and it's supposed to be raised to the power of the binomial minus the power of the first term. 4 minus 4 is 0. And so we can see here is 0, and then we just multiply this by 4, choose, again, it's supposed to be the power of the second term, and that's going to give me what? It's going to give me x to the power of 4. Let's start something like x to the power of, obviously here we decrease this by 1, and thus increase this guy by 1, multiply this by 4, choose 1 as the power of the second term, and that should be 6, I believe. No, 4 choose 1 is supposed to be 4. Now 4 times 2 is supposed to be 8yx cubed. Let's try the third term, which is going to be x to the power of 2 multiplied by 2y to the power of 2, and then obviously 4 choose 2. That's going to give me, as we know here, 4 choose 2 is supposed to be 6, and 6 times 4, 2 squared is 4, is supposed to be 24, and thus what we're going to have here is 24 y squared x squared. X to the power of 1 times 2y to the power of 3 times 4 choose 3, which is supposed to be 4 times 8, which is supposed to be 32 y cubed x. Last term is going to be x times 2y to the power of 4. Now it's supposed to be to the power of 0, and then times 4 choose 4, which is just going to be to the power of 4, which is 16 y to the power of 4. Now let's start another example. I'm going to have 3x minus 2y to the power of 5. And so what happens here is that we're going to start with the first term raised to the entire power of the binomial, the second term raised to the power of 0, multiply that by the power 5c, power of the second term. And that's supposed to be 3 to the power of 5, which is just 243 x to the power of 5. Now for the second term, decrease this power by 1, increase this power by 1, and then multiply this by 5, choose the power of the second term. And so what you're going to get here is supposed to be 2 minus 2 times 3 to the power of 4 times 5, which is also minus 810 x to the power of 4. Next term is going to be the third one, 3x to the power of 3 minus 2y to the power of 2, and then multiply that by 5, choose the second power, and that's supposed to be 1080, but then we're going to have x cubed, oh I forgot the y here, x cubed y squared. Fourth term now, 3x to the power of 1 times, of 2 minus 2y to the power of 3 times 5, choose 3, and that on the calculator is supposed to give you minus 720, and then x squared y cubed. Now, if we have something like this, obviously, which one have we reached? Of fifth term, 3x to the power of 1 times minus 2y to the power of 4 times 5, choose 4. That's supposed to be 240 x y to the power of 4. The last one is going to be 3x to the power of 0 minus 2y to the power of 5 times 5, choose 5, which is going to be minus 32 y to the power of 5. So these are all the terms, that write them down in a straight line together. 243 x to the power of 5 minus 810 x to the power of 4 y plus 1080 x to the power of 3 y squared minus 720 x to the power of 2 y to the power of 3, and then plus 240 x to the power of 1, y to the power of 4, and lastly minus 32 y to the power of 5. And you can see here that the power of x decreases by 1 along the terms, the power of y increases all the way from 0, because anything to the power of 0 is the equivalent of 1, and then all the way until 5, which is the power of the binomial. And notice here that when there was a negative sign in between the two, the signs between the two terms alternate, negative and then positive and then negative and then positive and so on, starting with positive at the first term. And so here you can see that if you have something that's negative in between, let's say you have a binomial expansion and there was a negative in between them, you know there's a mistake if you didn't have an alternation in your signs when you expanded everything. Alright, now let's try something else. Let's try something like this question. 2x minus 1 over x to the power of 10. I would like you to find the first 4 terms of this expansion. So here are the terms that you're supposed to get. Obviously, I don't want you to find all this. I just want you to find the first 3 and check them. And as you can see, the powers are alternating between positive and negative because there's a negative sign in between. And you can see also that the power here is decreasing by 2 rather than being decreasing by 1 because the x here is in the denominator, and so that obviously changes the result of the sequence. Now we're going to move on to the next example. Now he may ask you to find a specific term in that what's it called expansion. So if he says, for example, I want to find the x raised to the power of 2, or I want to find the term independent of x in the expansion. So to find, let's say, the term independent of x, that means the term does not even have x. So that means that the power of x is 0. Now when is the power of x 0? That depends upon the sequence, or let's say the binomial that you have. So something like 2x minus 1 over x to the power of 10. The here in this example which we did before, the x had a power of 0 when both. You can see here the term independent of x was this one, and it was when both of them were raised to the power of 5, and that way the x's cancelled, right? And so in something like this, I wouldn't ask you to expand all the way until here, no, but rather I would ask you to guess where you're going to have that term, when you're going to have the x's cancelled. And so looking at this, I think it's pretty easy to ask you to identify the term where the x is just not available. That's going to be the term where the power here is the same as the power of the second term. How about this one? Can you find the term independent of x in this expansion? Obviously, you wouldn't have to go through the entire sequence to, find that term. You just need to do a little bit of guessing. So you know here that the power varies between, let's say, 8 and 0, then 7 and 1, and then, what's it called, 6 and 2, and let's say raised to the power of 7. When it's raised to the power of 7, and this one is raised to the power of 1, the difference is going to be, it's 1 over 2x, and the whole thing is raised to the power of 7 times x to the power of 3. So what you're going to wind up with is something with x to the power of 4 at the bottom. Okay. So we're going to cancel this out, or at least eliminate it in your mind. Okay, you wouldn't have to actually find the term with x to the power of 7. Just think about how the x's interact. Let's look at the other one. How does the x interact in this case? You're going to have 1 over something like this, right? The x is at the bottom, and the whole thing is raised to the power of 6. And you're multiplying this by x to the power of 3, and the whole thing is raised to the power of 2. So that means that here this is going to be raised to the power of 6, and this is going to be multiplying to give me also x to the power of 6, which is going to cancel because 1 over x to the power of 6 times x to the power of 6 is supposed to be just 1. So this is going to be the term independent of x, and this term is going to be the term where the power is 6 and 2, 6 obviously respectively for the first and second terms. So let's try to find that term now. Obviously you don't really know the number of the term. You don't need to, because you know that the 2, which is the power of the second term, is supposed to give me the r, and the n is supposed to be 8. And so here I can apply the formula directly. I can say it's 8c2 multiplied by 1 over 2x raised to the power of 6 times x to the power of 3, and the whole thing raised to the power of 2. Let's see this one. If you have 2x plus 3 over x squared, and the whole thing is raised to the power of 6, and he wants the term independent of x. So first things first, I'm going to write 6c, something I don't know yet, and then I'm going to multiply this by the first term raised to a certain power, the second term raised to another power, but both powers are going to add up to 6. Right? So 3 over x squared, and then I know that 6 over here, if I, for example, start with 6, this is going to be 0. Now, this is obviously not eliminated, but let's try 5 and 1. It's still not going to be eliminated because it's going to be 5 x to the power of 5 here and x to the power of 2 at the bottom. Okay, what about something like x to the power of 2 and x to the power of 4? No, how about x to the power of 4 and x to the power of 2? Yes, which means that 6c 2. Why did I say x power 4 and x power 2? Because here, if you raise this to the power of 4, you're going to get x to the power of 4. And then x to the power of 2 raised to the power of 2 is going to be x to the power of 4, but at the bottom. And therefore, the x to the power of 4s are going to be eliminated. Now, when you use your calculator, 6c2 multiplied by 2 to the power of 4, and then 3 squared is supposed to be 2160. And this is the term independent of x. Let's try another example of the same sort. If we had something like x minus 1 over 2x squared and the whole thing is raised to the power of 9, and I want to find the term independent of x, so in this case I'm going to write 9c, or choose something, I still don't know the r, multiply this by the first term raised to a certain power, the second term raised to a different power, and we're going to see what is going to be necessary to eliminate them. So in this case, I think something like 5 and 4. No, because 5 and 4 is going to be a little weird. No. What about 6 and 3? 6 and 3 is actually going to work, because if I plug in 6 here, it's going to be x to the power of 6. If I put a 3 here, 3 times 2 is going to be 6. And so x to the power of 6 will be eliminated. And thus here I'm going to write 3, because we know that 3 is supposed to be the power of the second term. R is the power of the second term. Now, what we're going to do here is we're going to multiply on the calculator. 9c3 is supposed to be 84. 84 times x to the power of 6, and then times minus 1 over 8, x to the power of 6, and these two are eliminated, so it's just minus 84. And this is the term.